Welcome, everyone. Getting close to getting started. We do have a few seats kind of spread throughout the audience here if anyone's still standing and would like to sit. So my name is Alex Corley. I'm a senior solutions architect here at Amazon Web Services. I work in the state and local government area, so most of my customers are state agencies, municipalities, counties, different government entities at a state level. So I have a large background in automation. I joke I come from a long line of startups. Been an AWS customer for 8 years, been doing this DevOps thing for just about as long, right? And so we're gonna spend some time here talking today about the DevOps process, philosophy, how to apply that using AWS tools, and kind of comparing that against traditional on-premises architecture and how things will be a little bit different if you do choose to go greenfield, kind of new development in the cloud. So you hear a lot of people talk about DevOps, and we talk about tooling, we talk about culture. I'd like to spend a little time talking about philosophy. So Kaizen, the philosophy of improvement. So you hear a lot of people use the word continuous improvement. I feel that's a little bit redundant. You're never done improving, right? And also wanted to make a point that this is not just about technology, it's about business and people. And so I've got 2 quotes here, just wanted to read them real quick. You know, to me, this is the essence of what DevOps is. We're all participating in activities that continuously improve all functions of business and involving all employees, right? So you hear about breaking down of silos, the integration of business, kind of along that philosophy. And then also the reason we're doing this is because by improving standardized activities and processes, we can become more efficient and reduce waste, right? So going for greater levels of utilization, better efficiency. So comparing this with traditional on-premises infrastructure, right? Potentially these virtual machines have been running for months, years. You're using configuration management to do things like patch management, application upgrades, OS migrations, different things like that, right? Static DNS, maybe even static IP addresses. Definitely heavy on the configuration management, right? Kind of one configuration management to do your infrastructure, your application, your OS, kind of everything all in one. Traditionally, there's been challenges distributing secrets between all of these virtual resources, right? How do you do this efficiently and securely? The configuration management libraries tend to grow very quickly over time. If anyone here has been involved in writing cookbooks for more than one application, for an infrastructure at large, right? They begin to sprawl. You start having lots of logic in there. You end up having to write unit tests, functional tests, things like server spec, just to make sure that all of your configuration management is coherent in production. And then this adds thousands of lines of code for maintenance, for code review, peer review, right? There's a lot of work and infrastructure here. So here at AWS, you hear the term undifferentiated heavy lifting a lot. So this kind of goes back to those standardized processes that we're trying to automate for efficiency, right? It's necessary work and repetitive, but it can be automated. Originally with AWS, this was the pure infrastructure as a service, right? We took care of the concrete to the hypervisor. As we've grown as a company, as our customers have become more mature and the ecosystem has grown, we've now grown that undifferentiated heavy lifting up the stack, if you will. So it's no longer just data centers and compute, but we can actually talk about configuration management, application deployment, logging, monitoring, and metrics, right? These are all services that we offer that you as a customer with a configuration item or a small amount of automation can choose to leverage instead of carrying all of this traditional configuration management into the cloud that you may have in your on-premises data centers today. So one of the big reasons cloud is different, right? With AWS and EC2, we have a feature called auto-scaling. This allows you to dynamically grow and contract a horizontal scaled cluster based on utilization metrics. So the most popular example for this is a 3-tier web application that the web tier grows in response to incoming web load, right? This could be a peak advertising event or a time period during the day. And then at the end of that, your fleet contracts down to be more efficient, to save you money, so you're not over-provisioned for the lower utilization that you're experiencing at a different time. And so the reason this is really important and kind of a key concept as we go through this talk, the bottom point there, patching and long-term maintenance, is replaced by base images. So we have something called the Amazon machine image, which is essentially a disk image, if you're familiar with VMDKs or other kind of virtualized disk images. Instead of your convergence of your configuration management laying down dependencies, so if you have a Python project or a Ruby project, you're potentially installing Ruby, Ruby gems, pip packages, those types of things. Kind of the key point here is you should roll those up into a base image so that through the rest of this talk, we're kind of starting with that base artifact. It's a golden image. You can apply your company and corporate governance policies to this, your corporate InfoSec IT security policies to this, in addition to your development policies, right? So ensuring that only certain dependency chains are installed and used and available for the developers as we move forward in the workflow. So taking this base image and moving forward, we have an operating system and we have a basic kind of language environment, if you will, Python, Ruby, Java. We can apply that through a number of other configuration management and application deployment products inside of AWS. So we've got CloudFormation, CodeDeploy, Ops Works, and Beanstalk. And we're going to deep dive into each of these as we go through. So looking at CloudFormation, it's one of the base infrastructure layers, right? All of the other services kind of build on top of it. You can use other services in combination with it, or you can use them all separately, depending on the actual problem set that you're attempting to solve. And so CloudFormation is base infrastructure. Ops Works is service orchestration. CodeDeploy is straight application deployment. And then Beanstalk is a relatively full managed application ecosystem. If you don't need the full control of the other products, we can take a lot of that management overhead for you. So just going into CloudFormation, you can declare all of your components in a JSON template. You treat this as your concrete, right? Once it sets, you don't want it to change, really. And so you can lay down your network topology, your subnets, your security groups, auto-scale groups, identity and access management users, load balancers, right? All of the core architectural components. You keep this in a single file under version control. You edit the file and then feed it to CloudFormation, right? There are no changes outside of the ecosystem. What this does, it allows CloudFormation, when you go and submit changes, it will actually tell you the intended delta that's about to be deployed, right? So if you change a security group or change a subnet, when you go and relaunch that template, you'll actually get an idea of what's going to change before it actually occurs. And so this, again, allows you to keep all of your infrastructure in version control. This is just an example of a CloudFormation template. You can package your entire infrastructure in a single file. So the idea for this is to reduce deltas, right? The traditional works on my machine problem, right? This kind of takes that away in the this works in my account problem, if you will. And so what it does is it allows a repeatable resource to be deployed across organizations, across different companies, different divisions, and allow everyone to have a common infrastructure set that they can build upon. You can replicate this across multiple regions, multiple accounts, and multiple environments. And we'll have some details on kind of how you can do different dimensions with these. So some of the helper applications for CloudFormation, CFN HUP essentially detects changes to the CloudFormation template level and will then re-trigger processes on the individual EC2 instance. One of those processes is CFN Init. It's one of the configuration management tools that's part of CloudFormation, allows you to pre-install packages, pre-install or start and stop services, really gives you kind of that middle line of, I have things pre-installed at a language and dependency level. Maybe your CFN init comes in and pulls down kind of the role of the machine, right? What application am I supposed to be running so that I can then start to deploy that application? This is just a sample of a CloudFormation init section. Again, kind of building on this base image philosophy and kind of combining that with the item potency philosophy of configuration management, right? If we run something once and it doesn't need to be run again, we won't perform that action a second time. And so what this is essentially doing a chef run of only the application cookbook, right? Because in theory, this base image already has all of the dependencies required for the application. We're not going and installing Apache, we're not installing the database, you know, all of those would have been kind of there and ready for you. And again, one of the big reasons for this, going back to the auto-scaling, is if you have a 3-tier web architecture and you're experiencing some volatility in your utilization, you don't want a machine to spin up, take 20 minutes to converge your application install and not actually be able to respond to user traffic. So the theory here is we're cutting that time to market, if you will, for the application so that we can auto scale, you know, rather dynamically and have some agility within, you know, a five-minute period or less than that to be able to respond to increased load. So we talked a little bit about CloudFormation, which is really infrastructure focused. It can run commands on the machines to do application deployments, but it's not going to support a lot of the advanced features that CodeDeploy does. So CodeDeploy is going to be an agent-based service. It'll work on Windows or Linux. You can use it to deploy your application to any machine that the agent is running on. This could even be on premises. And it takes similar philosophies from other application deployment frameworks, right? There are lifecycle events. So before the application starts, you can perform some pre-configuration or some sanity checking. Before the application install, you can do things like verify that the dependencies you think are part of that base AMI are actually there, right? Kind of that trust but verify philosophy. And then the validate service, I think, is very important, right? This is the way to build in sanity checking to your application health, right? Did the application boot up fully? Is it behaving as we intend it to? Is it responding and ready for customer traffic? Gives you a lot of flexibility to influence the application deployment workflow there. So just kind of deep diving a little bit into a few of these deployment philosophies, right? We can do rolling deployments. So you can say, I would like to verify that this code works on 10% of my fleet before I roll it across the other 90%. You can do semantic versioning deployments and rollbacks, right? So if you're going from 1.2.0 to 1.3.0, you have full support. Let's say if it fails that validate service check, to roll back to 1.2.0. So it gives you a lot of flexibility on actually managing the application lifecycle of deployments and rollbacks. And then also what this allows you to do is decouple your application from your infrastructure, so that your application development teams work only with the application layer or the application code, and they're not concerned about security groups, subnetting layouts, network ACLs, routing rules, you know, all of the base infrastructure that they care about because their application needs to function, but we can start extrapolating these so that we can start building least privileged and separation of duty type scenarios here. So going into Beanstalk. Beanstalk's a little bit more aimed directly at developers. It's a fully managed ecosystem. You can choose a language and feed it a zip file, and it will execute for you with a small amount of configuration. You can deploy a load balancer, an auto scale group, a multi-AZ RDS instance, and we handle all of the management of those resources for you. You define some CloudWatch metrics on how it's going to behave when it scales up and down, but we manage the deployment of the application to that infrastructure, ensure that the load balancer health checks are functioning against the application, right? A lot of pre-configuration, but really developer focused. Fast and simple, again, aimed at productivity, pretty much impossible to outgrow. It's based on auto scaling and load balancing. And complete resource control. So you can choose to use one of our pre-baked AMIs that has a language environment already on it, or you can bring your own AMI that you've already put an application language environment on, plus all your governance and IT policy, right? So just kind of looking at Beanstalk here in a general architecture view. So as I said earlier, we take care of the capacity provisioning, the load balancing, the auto scaling, the health checks, CloudWatch metrics. With a small amount of configuration, you can add log shipping to this. All of these EC2 instances could log either the web logs, the application logs, all to CloudWatch logs. So it gives you the ability to really tie in the entire ecosystem around your application artifact. Instead of trying to develop a lot of this on your own, it's essentially best practices codified into an architecture. Support a lot of the major languages and frameworks, so PHP, Python, Java, Ruby, Node, Go, and then it also will run Docker containers. So if you've gotten kind of the container level of removing deltas in between development local environments and production environments, it will support the Docker workflow to get those containers from the developers to production. Talk a little bit about Ops Works here. So Ops Works is a configuration management service orchestration tool. It's currently based on Chef. Allows you to do a lot of things maybe you're currently doing on premises or with a third party, but all within the AWS ecosystem, right? You never have to reach out to the internet in order to leverage these orchestration services. All of the identity and access management, certificate management, all of the internal security and secret sharing can be managed through OpsWorks, things like identity and access management roles, instance profiles, really allows you to tie everything together in a cohesive unit. Allows you to do things like building self-healing architectures. So again, with auto-scale groups and health checks, if one of these machines fails a health check, either due to a failed application deployment, potentially an OS defect, or an underlying hardware failure, we can replace that automatically. And as long as your application supports some of these deployment workflows, when that machine comes up in a small amount of time, it's healthy again, right? So when you treat these as groups of resources, one of them can become unhealthy, and you think kind of herd immunity and some of these other things, right? We can remove that one unhealthy host and replace it with a healthy one, and overall, the cluster still remained healthy the entire time. You can use this to kind of lovingly craft each individual instance if you want, or you can treat them all the same, right? So different levels of scale as far as how you could implement this. And then it also supports lifecycle events just like CodeDeploy. So you can respond to changes in your infrastructure or to events that occur within your application and actually trigger changes inside of your infrastructure. So just kind of looking at this diagram very quickly, you can kind of see we've got 3 tiers here. We've got 2 different application servers and a database server. Each one is a layer in the OpsWorks stack. And so we've got a little bit of color coding down at the bottom to kind of denote the legend of actions. But you can see we start with a single app server with a setup lifecycle event. That then triggers a configure of that first app layer. The next lifecycle event is a deploy, right? So that's a deploy of the first app layer. The third one is another setup, but this is going to be at the database layer. That allows you to trigger events across multiple other layers, right? So the one setup of a database not only triggered the configuration of the database, but it also triggered the configuration of the application server. So that once the database comes up and you know the DNS endpoint or the private IP address, maybe the user credentials associated with that, you can then use service orchestration to trigger the application configuration so that it can configure itself to talk to that database, right? The fourth one here is deploy application again. And this is to potentially reconfigure anything that needs to change. If the application needs to start talking to the database to maybe instantiate a base schema or something like that. But again, across multiple layers. To the sixth one here, we've got start the second app server, which again triggers multiple configurations. At this point, I don't know if there'd be much that would change on the database machine, but it would trigger both application configurations to ensure that they could both talk to the database at that time. At that point, we can do things like maybe change user permissions, maybe do a rollback of the application, some sort of lifecycle event. And at that point, again, we can trigger additional actions. And so after the change user permissions, we go and stop the application server. And at that point, it triggers, okay, well, let's stop the database and let's stop the secondary application. There were a dependency between the two. All right, but it allows you to build logic around larger building components than you previously did when working with service orchestration. So I've talked a lot about kind of POSIX, open source, Linux projects. Really want to talk a little bit about Windows. So we do have the simple systems management service that we offer, and it's a middle ground kind of between CFN, Init, and SCCM or something like that on the enterprise level. And so if you are a Windows shop and have a lot of Windows competency, this can be a good part of your workflow. So what this does is it allows you to do MSI, it allows you to do PowerShell modules, not just execute a PowerShell command, right? You can actually deploy part of your governance and management workflow into this if you are based on PowerShell. It allows you to automatically configure CloudWatch metrics and logs because it is a Windows service that runs. It can tie into Event Viewer, a lot of the other kind of Windows native services so that you get inherent log shipping, right? You can send these to CloudWatch logs. You can define custom CloudWatch metrics that are specific to your application. So by default, the auto-scale metrics are CPU utilization, disk I/O, and network throughput. What if you really would like to scale on the number of concurrent users, or maybe the API latency of a particular endpoint, right? As the latency increases, we would like to add more servers to reduce that latency. These are all custom CloudWatch metrics that you could, through a configuration file and the simple systems management service, actually tie all of those services together. Just really want to point out that this is meant to be complementary, right? This is just a kind of bootstrapping utility here to do really basic configuration and then kick off a greater application workflow, maybe the CodeDeploy agent or something like that, right? But some customers may not be able to 100% pre-bake all of their things into the AMI, and so this is kind of a nice middle ground where you can continue to use the management workflow that you currently have, but actually cloud native. I want to spend a little bit of time talking about infrastructure as code. It's definitely been woven throughout this, right? When I talk about version control, artifacts that are related to your infrastructure, such as the CloudFormation templates. These are things that you can semantically version internally to your organization. You can keep it in your version control repository. You can do things like add pre-commit hooks to this. So like the CloudFormation templates, you don't want to miss a comma or a bracket and have some malformed JSON and attempt to deploy that to production only to receive a CloudFormation error or something, right? So you can put different pieces of workflow in here, maybe your peer review process, right? All of these can be applied to your infrastructure, not just your applications. We're 100% API based, right? So pretty much anything you do in the console or through anything is code, and it's talking to us with code. This allows your operational resources to start scaling, right? And instead of through the console setting up a VPC, go ahead and define it in a CloudFormation template. Go ahead and type it out using the AWS CLI, right? Automate it somehow, put it into a script so that it's reusable and it's reviewable and it's version controllable. I wanted to talk a little bit about DevOps and security. So traditional security methods are kind of hard to scale, right? There's a change management process to get a firewall rule opened for an IP whitelist, or an application actually grows in scope and you need an extra layer in your network topology, right? Instead of DMZ, load balancer, web app database, maybe you need an additional AWS managed services subnet grouping or something like that. And traditionally, getting a new VLAN added or other on-premises kind of physical concepts, they take a lot of review and change management and time to go through that process. So what we're kind of purporting here is that you should leverage these version-controlled artifacts so that once they're reviewed once, you only need to review them if there's ever a change that occurs, right? These are not only reusable kind of from a human scale, but also a governance scale. If you have a networking team or a security team that is currently in charge of approving firewall changes or approving network topologies, these are things that they could do in a CloudFormation template and share that with other organizations inside of your company, right? So that you're using the golden network topology that has been approved by InfoSec and is known good for your application state. It allows you to start codifying and enforcing requirements. So if anyone's familiar with AWS config rules and Lambda, gives you near real-time governance, continuous monitoring, continuous remediation options for your infrastructure. And so if you know your security groups are under version control and you detect a delta inside of your ecosystem, right? A security group rule was changed. Let's fire a Lambda function. Let's go and look at what my definition of the security group should be. If there's any delta there, send alarms to the system administrators, maybe actually remediate the security group rule by undoing the previous change. A lot of power here. Also wanted to mention Inspector. So it's an agent-based service that does a lot of best practice checking at the operating system level. So we currently offer PCI and a set of common vulnerability scans. And so it'll do things like look at operating system config, Windows registry, some basic things to really start helping you down the compliance and auditing road. Want to look towards a toolbox approach, right? All of these tools here are very useful for different circumstances. I joke CloudFormation's the hammer, right? It's the first thing I pull out, and if I can't fix it with the hammer, then I'll go for the screwdriver. Want to point out that we're working on code. Everything I pointed out here involved committing to a version-controlled repository and then deploying that artifact. We never went to the console and clicked or typed or performed manual actions. These are really codified into an artifact, and then that artifact was applied, right? You never logged into a server. All of these were external actions. And then again, continuing to just leverage lighter weight, better managed services as you move up the stack instead of spending all your time focusing on application deployment methodologies, right? Just kind of build on top of ours. So just really quickly wanted to go over some ways to scale this. So front end, back end, identity and access management. We can go dev, staging, production, all with the same template. We can do service-oriented architecture. So if you don't want to do network layers and topologies, we can break these up into individual units and connect them all together. And then I've talked a lot about single templates. You can also nest templates. So in this example, over on the right, we have a networking stack and a DynamoDB database stack. And then on the left, we have load balancing and auto-scaling. You can combine these together so that the networking team is responsible for the networking security. The infrastructure team is responsible for the infrastructure integrity. And then when you combine them together, the application team now has a full environment and artifact that they can move forward with. So again, just some next steps. Lambda, please go look at Lambda. Event-driven computing is the future. And WAF. So we have the Web Application Firewall that allows you to place custom Layer 7 rules in front of your application so that you can start automating and scaling out your border perimeter security before things ever even get into your ecosystem. So I'm going to turn things over to Josh with Fugue here, and he's going to take it one step further and go from kind of base image plus some application deployments to what we'd like to call immutable infrastructure.
Yep. Thank you very much. Hi, everyone. Can you hear me? Good. I'm Josh Stella. I'm the CEO and co-founder of Fugue, and I'm an ex-AWSer, as are many of us at Fugue. So it's nice to be invited to this event, and thanks much to AWS for doing so. I'm going to talk a lot about immutable infrastructure today, and before I get into that, there's a lot of ways I can describe this. So it'd be helpful to me if you have been or are a developer now, could you raise your hand? Oh, good. Excellent. So immutable infrastructure is about automating for predictability, reliability, and scalability. I'll tell you a little bit about us as a company. Mostly I'm going to talk about the subject writ large. So Fugue was founded a few years ago. We're a venture-backed startup based here in the DC area. We're also out in Silicon Valley. We have developers all over the world. There are about 50 of us. If you met us on the booth on the show floor at this session, you probably know more, but you'll see more about us as we go forward. I founded the company because I saw there was a need to take a systems approach to a lot of this complexity. And so as we were working on this, O'Reilly reached out to us, and we authored a short book on immutable infrastructure, O'Reilly Report, which is available to you for free here today. So next slide, please. Actually, I think we decided the clicker actually works. All right, this is a quote from Chad Fowler. Chad Fowler is the guy who coined the term immutable infrastructure in 2014. So I'll go ahead and read it. The longer a system lives, the more afraid of it I become. An old system inevitably grows warts. They start as one-time hacks during outages, right? We have all done this. We'll put it back into chef later. The system becomes a house of cards. You fear any change, and you fear replacing it since you don't know everything. You don't know everything about how it works. That last sentence is really important. So think about the systems you have now. Do you know everything about how any of them work? And the answer is almost certainly no, if you're honest. So what is immutable infrastructure? Many of you have been programmers, right? So immutable, I think, is a little bit of an unfortunate term for this because it's not perfectly accurate, but it gets the right message across. So immutable data in programming is when you cannot mutate the value of data, right? You cannot change it. You must replace it. So where did this come from? That sounds like a pain. It is a little bit of a pain. Where did it come from? It came from building highly stable, reliable systems that are fully automated. So perhaps the most famous language that is fully immutable is Erlang, which runs telco networks, because those can't go down. So as you're building your cloud infrastructure, these immutable patterns have the same goal: full automation, high levels of reliability. So what does it mean in practice? So theoretically, it's related to this idea in programming. But in practice, what it means is once you instantiate something like an EC2 instance, you never touch it again, right? You destroy it and replace it with another one. There's other stuff, though, that you're not going to do that with, kind of a mental model in AWS, like a virtual private cloud. You probably don't want to tear down your whole network, build a new one, move all your stuff. So in that case, immutable kind of means it never gets changed except what's been checked into your source code repository. It is 100% code driven. So we like to think of building stuff and operating stuff on cloud not as a remote data center or infrastructure, but as a program, as a process, just like you would in memory on your local machine. All right, so why do this? What are some of the disadvantages for mutable? How did we get there? And what does immutable do for you? So first of all, I want to point out that we're all used to mutable infrastructure. We all do this because that's all you can do in a data center. You must do this in a data center because in a data center you have a finite resource that you recap every few years. You want to make sure everything's operating well. You're going to get the most out of that server you can over its life cycle. That's why we've gone down this road rather than the demonstrably superior road in the long run with cloud of immutable. So complexity increases with scale. If you're successful on cloud, you will have complexity at a level that you have never seen in a data center. So I'll describe success as the kind of high bar of success. If you talk to the Netflix guys, and I know some of them were here, you're talking about tens of thousands of compute instances at any one time that have average lifespans measured in hours. So think about if you can run Chef against that, or run your traditional data center models against that. It doesn't work well. You have slower deployments with more failures. You have opportunity for failure when trying to touch servers and make sure they're okay. You have to identify whether something has been corrupted or threatened. You have to notice if you've been hacked, right? In immutable, if you're destroying things and replacing them at a high frequency, it's much less of an issue. And you're going to have fire drills when things happen, like AWS has to say, for a region, we're going to do a scheduled reboot because we actually have to do some maintenance on the underlying hypervisor, which is rare, but it does happen. And that can cause a real headache. So in immutable, you kind of turn this whole thing on its head. It massively reduces complexity at scale because everything is automated. You speed deployments with fewer failures because, as we just saw, things are image-based. They're not process-based. They're not procedure-based. You're not going out and touching servers and modifying them. And you mitigate errors and deploy right over top of threats. Right? So if you have a server that is acting poorly and you don't know that, whether by malfeasance or error, it will automatically get corrected as part of the normal immutable infrastructure lifecycle. And if you need to reboot an application you're running in cloud, that's not a big deal because you're doing it all the time anyway. So is immutable infrastructure the right fit? I had mixed feelings about this title. I would say if you're planning on really doing cloud well, the answer is always going to be yes eventually. This is what you should be going towards. So this is really oriented toward, do I have a system that I can do using immutable patterns now? So the first one is, if you're designing something greenfield, then by definition you can, because everyone who's operating at really large scale successfully on clouds is doing it using immutable patterns. So you should do that. You'll save yourself a ton of pain later. The rest of these are for existing apps, but make a pretty good checklist of what to make sure you do for the greenfield app, right? So if it's capable of lights out headless booting, using ASGs, this fourth bullet, excuse me, is one of the tough ones, critically important. You've decided where to put your persistent state. You've decided where to keep all of your actual changing data, your databases. It's not smeared throughout your application to every different tier. You need a mechanism for automated updates, that's obvious. And AWS talked about this a fair amount. You need to move from configuration management in the traditional style to the kinds of patterns that you just heard about. So I say here, research suggests, this came from an AWS deck, so I didn't have a citation, but I'll try to find one. About every 10 days is a pretty good life cycle for compute instances. So this was an animation, and it didn't work on PowerPoint. So I've got some cups. So imagine this is your server, and when the cup is open to the top, it's running. In mutable patterns, you're going to run this server until it needs maintenance. Then you're going to flip the server over. Hopefully you've got enough other servers in your cluster that your application is still running, but you might get one of those services in maintenance right now. We appreciate your patience. And then later you'll turn it back over. So in Immutable, you do this completely differently. You have a server that's up and running, and then you build a server next to it that is not in the distribution yet for the actual application. Then that one comes up, and you might do a blue-green. You might decide to keep both up for a while and see what happens. But ultimately, if this new one was successful, you're going to turn this one off, and you're going to crumple it up, and you're going to throw it away. So that's how Immutable works, and I owe Werner Vogels for that analogy. He calls it paper cup computing, and he's exactly right. I had plastic cups, but works about the same. So how do you do it? AWS just gave you a really good tour through a bunch of the awesome tools in their toolkit they have for doing this. But you saw there are quite a few of them, and they are all APIs. So as you're looking at this, and you're seeing, there are a fair number of moving parts here. You can script those things. If you're advanced and you really understand cloud, you can integrate them yourself. You'll see, again, like Netflix kind of wrote their own operating system, if you will, for living on top of AWS at scale. So I'm going to talk a little bit about Fugue, because Fugue is a general purpose operating system for automating all these things at scale on cloud. So rather than Netflix having to kind of do their own integration, every customer on AWS, you at a certain point you realize you've got this big code base of glue code to make everything work. So we kind of went to first principles and tried to solve this more generally so that this stuff is really easy for you to do. So Fugue is made of two parts. The first is Ludwig, which is a language by which you can design cloud infrastructure. And the second is what we call a conductor, which is roughly analogous to an operating system kernel. It is a program that builds, operates, maintains, destroys everything on cloud. Those are the two parts. So I'm going to go into a little bit of detail on both of them. Ludwig programs are not templates. They're real programs. There's a compiler, there are error messages, there is a help system, there is a full module system. So this, if you're used to programming in programming languages, it can be hard to go to managing templates. So we put a ton of work into making Ludwig really powerful, really easy to use, and you will not be surprised that Ludwig only has immutable data. It is based on the same functional programming patterns that Erlang and Haskell and others have. So there's really rich power in Ludwig. You can define everything. The compiler will tell you whether or not you're going to be successful. And then the conductor builds everything. And you'll notice deploy is one of two steps. And deploy is the easy part, is what we've learned over the last couple years building this. Getting things built on AWS is easy. And tearing them down is pretty easy too. It's the life cycle in between that gets really complex. So the conductor, again, it's like an operating system kernel. It's going to build out the infrastructure you declare, but then it's going to maintain and operate it. So it's going to constantly monitor it, and you don't have to configure anything to do that. If you put something in the Ludwig declaration, it will be enforced. Period, full stop, 24/7. So that is really powerful as just a simple way to deal with all of this complexity. And we love all these AWS services, so we support most of them now. We are going to support every AWS service in the very near future, so we will be in sync with AWS as they roll out services and features. This is just a code fragment. I think I might be running, yeah, I have 27 seconds, so I won't spend a lot of time on this code fragment, other than to say that's an entire VPC and 9 lines of code on the left, and there are a lot of, if you look at some other ways to do this, you'll find that's kind of unusual. So you can get early access now. We are in beta, and we are going to go live this summer with the 1.0 of the product. We'd love you to come to fugue.co and take a look, sign up. And this is, on the right is the Immutable Infrastructure O'Reilly report that we authored with O'Reilly. We've got a stack of them here. I've got some folks over here in Fugue t-shirts. You're welcome to grab one on the way out. And thank you very much for your time, and thanks again to AWS for inviting me.